So we started about the law of universal law of gravitation, and we said that this universal law of gravitation was actually given with the help of Kepler's laws. Three Kepler's laws, out of which first law was that the planets revolve around the sun in an elliptical orbit, not a circular orbit, but a elliptical orbit, and the sun being at one of the focus. Sun being at one of the, every ellipse has got two foci. The sun will be at one of the foci. Then the second was the area swept by the line joining the planet to the sun, planet to the star. Line joining the planet to the area swept by this line in equal time intervals is equal. In 10 days, if it sweeps this much area, and another 10 days it sweeps this much area, then this area and this area are going to be equal. That is the equal areas. And the third rule which we were going to study today, let me read it again. The orbit of a planet is an ellipse with the sun at one of the foci, as shown in the figure given below. In this figure, O is the position of the sun. The line joining the planet and the sun sweep equal areas. That means this area AOB in equal intervals of time. Thus, if the time interval from A to B, suppose the earth reaches or the planet reaches from A to B in 10 days, and same time, that is from C to D, it also requires 10 days, then the areas AOB and OCD are always going to be equal. See, it is about the motion of the planets, and we have got that their areas are equal in equal intervals of time. Such a unique thing it is, and that too when it is not a circle. अगर ऑर्बिट सर्कुलर होता तो भी हम लोग समझ जाते कि चलो ठीक है, because radii are equal arcs will be happen and equal sectors will form. But here neither the radius is equal nor it is going to form equal sectors. Still the areas are coming out to be equal. And then the third law, the cube of mean distance of the planet from the sun, that is the distance of the planet in सबका average, cube of mean distance, the mean distance cube of that is r cube, is proportional to the square of its orbital period. Means here, if the distance between earth and sun is say 6.6 into 10 raised to 6, then 6 and the time period required is 365 days. So that 6.6 into 10 raised to 6 whole cube is proportional to 365 square. Cube of the distance is proportional to square of the time. Okay, you will write it like this over here. Write it in a simple way. For third law, you can write it like this. Write here in a small pencil. Cube of distance proportional square of time. So r cube proportional t square. Correct? It is important to note that this is the third law. This is the third law. Cube of distance is proportional to square of time. Kepler could not give a theory to explain the motion of the planets. It was Newton who showed that the cause of the planetary motion is the gravitational force that the sun exerts on them. Newton used the third law, r cube proportional t square, third law of Kepler, to calculate the gravitational force of attraction. The gravitational force of the earth is weakened by the distance. A simple argument goes like this. We can assume that the planetary orbits are circular instead of ellipse, or assume it to be circular. Suppose the orbital velocity is v and the radius of the orbit is r. Suppose the radius is r, velocity is v. Then force acting on an orbiting planet is given by force proportional v square upon r. Force is proportional to square of velocity divided by r. If t denotes the period, then v is equal to 2 pi r upon t. All these things are there. It is not important for you. You will just remember this thing. Force is proportional to 1 upon r square. Using all these things, what Newton found out is force is proportional to 1 upon r square. And that is why what did we get? We got force proportional m into m, mm, force proportional 1 upon d square. D is the distance. And here r is also the distance actually between the two bodies. Yes or no? This is how we got the universal law of gravitation. Yes or no?
Yes, sir.
Yes, sir.
Fine. And then the SI unit we found out, it is Newton meter square per kg square. The value of GV was actually found out by Henry Cavendish by using a sensitive balance, and accepted value, I told you, it is already, I've already told you the accepted value of G. G is equal to, write it over here, G is equal to 6.673 into 10 raised to minus 11 Newton meter square per kg square. We know that there exists a force of attraction between any two objects. Compute the value of this force between you and your friend sitting close by. Conclude how do you do not experience. Why we don't experience this force? Tell me, we have already done this thing. Why don't we experience this force?
Because it is very less.
Very small. We found it now that it was almost 0.000000134 newtons. Yes or no?
Yes, sir.
The law is universal in a sense that it is applicable to all bodies. Why it is universal? Because it is applicable to all bodies, whether the bodies are big or small, whether they are celestial or terrestrial. Celestial means what? And terrestrial means what? Celestial means what? Whatever is in the universe, space. Anything that is in space is called as celestial. Anything that is on the earth is called as terrestrial. So this law of gravitation is applied to all the bodies. It is applicable to all the bodies, whether they are the bodies in the space, objects in the space, or objects on the earth. Any and every object's law of gravitation is applicable, and hence it becomes the universal law of gravitation. Am I clear?
Yes, sir.
Fine. Then they have given an example. The mass of the earth is 6 into 10 raised to 24. So what is given? M1. Yes or no?
Yes.
Mass of the moon is this, so M2 is given. Distance between the earth and moon is given, so the distance is given. Calculate the force. We can find out the force now. How do we find out the force? Force is equal to G M1 M2 upon D square. Yes or no?
Yes.
G is given, M1 is given, M2 is given, D is given. So the force of attraction between earth and moon they have found out by putting the values. How much force? C. Thus, the force exerted by the earth on the moon is 2.02 into 10 raised to 20 newtons. Such a big force is it. Such a big force is the force exerted by the earth on the moon. Do you understand?
Yes, sir.
Next question, state the universal law of gravitation. We have already stated. Write the formula to find. We have already done. Another importance, very important question. Mark here, star mark. Important question. It will come into the exams. What is the importance of the universal law of gravitation? Why is this universal law important? How did it help us? The universal law of gravitation successfully explained several phenomena which were believed to be unconnected. Dekho, the force that bind us to the earth, the motion of moon around the earth, the motion of planets around the sun, the tides due to the moon and the sun, all these things, all these forces, they seem unconnected, but they are actually connected. Why they are connected? Because all these motions, which motions? We getting binded to the earth, we always stand on the earth, we are not flying or floating on the earth. Moon revolving around the earth, earth revolving around the sun, or the tides that are formed because of the gravitational force applied by the sun and the moon. All these things, they are interconnected in a way that they all are because of the gravitational force. They all are because of some or other gravitational force. We are attracted towards the earth because of the gravitational force exerted by the earth. Moon revolves around the earth again because of the gravitational force exerted by the earth. Earth revolves around the sun because the sun attracts the gravitational earth with the gravitational force. In the daytime, the tides are formed because of the gravitational attraction of the sun. In the night time, the tides are formed because of the gravitational force applied by the moon. Are you understanding?
Yes, sir.
Yes.
That is the importance of universal law of gravitation. Let us move ahead. Another concept, free fall. Another concept, free fall. I will demonstrate a free fall. This is a free fall. This is not a free fall. You tell me which is a free fall, which is not a free fall. Again, I will show you example. Just see here. This was a free fall. Wait. This was not a free fall. Means what? Who can tell me?
In second one, you applied some force to push it down.
Exactly. So when object, see, I'm just leaving the object. Whenever an object falls down freely without the application of any other force, only because of gravitational force, it would be called as a free fall. On the other hand, if I throw something down, it has got two forces. Already the earth is pulling and I have thrown it. See, that is why when it comes down like this and when I throw it like this comes faster because two forces are acting. Can you understand that?
Yes.
Yes, sir.
And that is
Yes,
why
sir.
it is called as a free fall. Which one? Now see, when I throw this upwards, again it came down. So it went up to a certain height because of the force that I applied. It stopped and then it came down freely without any. Did I take it down? No, I just pushed it up, but still it came down. It went up and came down. Now while coming down, it was only under the influence of Earth's gravitational force. And that motion, underline, that motion which acts only because of the influence of Earth's gravitational force is called as a free fall. Is called as a free fall. Correct?
Yes.
So if I stand on the top of a tower and throw a stone at my friend, will it be called as a free fall?
No.
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 But if I stand at the top of the tower and just leave a stone and it goes and falls on the head of my friend, will it be a free fall?
Yes.
Yes.
Yes, because it came down only because of the influence of the gravitational force. Let me read what they have to say over here. Free fall. Let's try to understand the meaning of free fall by performing this activity. Take a stone, throw it upwards, it reaches a certain height and then it starts falling down. We have learned that the earth attracts the objects towards it. This is due to the gravitational force. Underline the next line. Whenever objects fall towards the earth under the force alone, which force? Gravitational force. Under the gravitational force alone, we say that the objects are in a free fall. Correct? Define free fall. It is right here. Immediately right here the question. Define free fall. Okay. Yes or no?
Yes.
Yes, sir.
Is there any change in the velocity of falling objects while falling? Tell me. When an object is falling down, do you feel that there is any change in its velocity? Direction is same. It is downward direction only. No other change of direction. But is there a change of speed? Is there a change of velocity?
No.
See, velocity changes because of two things. Either you change the direction or you change the speed. Direction though is not changing. What about speed?
It's not
So it
changing.
will change.
It is actually changing. If you know, these motions are very, very small. We can't understand. But you, if you were, I'll tell you one example. I will tell you one example. Suppose you are standing on a 5-story building. 5 मंजिले की building है, 5-story building. And you fall from a 5-story building. You fall down from a 5-story building. And you fall on your hand. What will happen?
Fracture.
Certainly, 100% you will have a fractured bone. Your bone will crack because of the impact. Am I right?
Yes.
Same person falls from a height of 3 feet. ऐसे बेड पे खड़ा है, बेड से नीचे गिर गया. Are you sure that his hand will get fractured or he will only get hurt?
No.
He'll get hurt.
He will only get hurt. Only from a bed he has fallen down. Only from a bed he has fallen. The same person. Same person. Why did he fall from the bed? Why didn't he go up? Because of the gravitational force. है ना? Bed से अगर उसने jump किया, if he jumps from the bed, he will definitely fall down on the floor. If he jumps from a 5-story terrace, he will again going to fall down on the floor only. Or from bed, he's going to fly high in the air. Or from the story, he's going to fly high. He cannot fly high. He's going to fall down only. Am I right?
Yes.
In both the cases, he is falling down because of the gravitational force. So person is same, force is same. Which force? Force of attraction is same, but the impact caused is more. Why? Because when you fall from the bed, small distance was traveled, small velocity was generated. बहुत आराम से गिर गए तुम, इसे बहुत जोर से नहीं गिरे. You didn't fall very fast. You didn't fall in a very fast manner. You fell just slowly. But when you fall from the top of a 5-story building, by the time you reach 5 stories, the velocity is increased tremendously and dhadam karke you fall down. You fall down very heavily. Yes or no?
Yes.
That means as the distance increases during the free fall, the velocity goes on increasing. From the 5th floor, by the time he reaches the ground floor, he has gained a tremendously high velocity, and that is why dhadam karke he falls down. If you don't want to imagine that case also, you do one thing. You just take your mobile in your hand and throw it like this, 2 feet from here. Count the noise and then go at the terrace of your building and then throw it from there. And then you can hear the noise. Which noise will be bigger? Check it and do which noise will be bigger, whether you throw it from your bed or whether you throw it from the 5 feet, and then you'll understand. Because definitely when you and do one thing, throw it exactly on some glass. एक कांच का टुकड़ा रखो. So when I throw it from here, the glass may break or may not break, but if I throw it from 5th floor, definitely the glass is going to break. That is what happens. The velocity, the speed continuously increases. See, as the distance decreases, as the distance between the earth, when I'm standing on a 5-story high, I'm at the top. But as I come down, the distance is decreasing. And the force is inversely proportional to the square of distance. So if the distance increases by 6 times, the force decreases by 36 times. But when the distance is continuously decreasing, as the denominator is decreasing, the numerator is increasing in inverse proportion. As the distance decreases, the force increases. Am I clear?
Yes.
Yes, sir.
And this velocity is uniformly increasing because I'm uniformly falling down. 1 meter, 2 meter, 3 meter, 4 meter, 5 meter. And uniformly square say the force is getting increased, means there is a uniform change of velocity, and that is why the free falling action, the free falling motion is always a uniformly accelerated motion. I had told you in the beginning chapter of motion also, a free fall is always a uniformly accelerated motion. Why? Because the direction doesn't change, but the speed definitely changes as you fall down. Why the speed changes? Because it depends upon the force. The force of attraction is inversely proportional to the distance. As the distance decreases, the force increases. As the force increases, it pulls with a greater force, the velocity increases. Change of velocity means acceleration. Uniform change of velocity means uniform acceleration. And this freely falling motion is always a uniformly accelerated motion. Correct? Yes or no?
Yes, sir.
While falling, there is no change in the direction of motion, but due to Earth's attraction, there will be a change in the magnitude of the velocity. Any change in the velocity involves acceleration. So, whenever an object falls towards the Earth, an acceleration is involved. This acceleration is due to the Earth's gravitational force. Therefore, this acceleration is called as acceleration due to gravitational force, or it is called as acceleration due to gravity. it is denoted by G, and the unit is same as acceleration, that is meter per second square. So this is a new concept. This acceleration is called as acceleration due to gravity, that will be denoted as G. That will be denoted as G, correct? Just as we have force is equal to mass into acceleration, F is equal to ma, the same ma now becomes F is equal to mg. Because why? This acceleration, in which case? In a freely falling motions case. Whenever I am falling downwards, the acceleration is due to gravity. It is taken as positive. We have found out the value also. The found out value of G is 9.8 meter per second square. If not given, 9.8 is approximately equal to 10. To simplify the calculations, whenever the value is not given, the value will be taken as 10. If they have specified to take acceleration due to gravity as 9.8, that G will be taken as 9.8, but that G is nothing but A. G is nothing but A. So here you're going to write it over here. किधर गया है नोट? A is equal to G and meter per second square. Where is that anode? Okay. Now we know from the second law of motion that actually anode करके गलती हो गया. What am I supposed to? Yeah. A is equal to G. And then see, we know that. So force is equal to mass into F is equal to ma actually. And now A is replaced as G. So F is equal to mg. So now see, this F is actually equal to what? Gmm upon d square. So mg is equal to gmm upon d square. Can you understand that? We have substituted the value of F as mg. Yes or no?
Yes, sir.
And F is already gmm upon d square. So in place of F, now we are putting mg, mass of the object. G, capital M is mass of Earth, small m is mass of the object, divided by distance between Earth and object is the radius of the Earth, square. Small m here and small m here gets cancelled. So ultimately, your G becomes G into capital M upon R square, Gm upon R square. Put the values of Gm and R square, you get the value of small g as 9.8 meter per second square. Correct, Aika? Are you understanding?
Sir.
Yes or no?
Yes.
So what is the value of small g? What is small g equal to? Acceleration due to gravity. Capital G into M upon R square. Remember this thing. It's a very important formula. Just a minute. You write down this somewhere in your notebooks. You write down this somewhere. I'm telling you what is to be written. ये लिख लो जो मैं लिख रहा हूँ अभी यहाँ पे फटाफट. Finding the value of G. Acceleration due to gravity. Finding the value of acceleration due to gravity. In that, start writing. This is the you will need this sometimes, the derivation also. So let me write it. According to the universal law of gravitation. What happens according to the universal law of gravitation? Say fast. F is equal to
Gm1 m2 upon d square.
or gmm upon d square. You are right. Equation 1. And according to Second law of motion, F is equal to ma. Yes or no?
Yes, sir.
F is equal to ma is equal to mg. Yes or no? Because A is now G. Equation 2. Yes or no? Reason.
Yes.
Since for a free fall, A is nothing but G is acceleration due to gravity. Yes or no?
Yes.
From 1 and 2. From 1 and 2, I'm going to get G M M upon D square is equal to mg is equal to mg. Small m and small m will get cancelled. Now wait a minute. So you're going to get G is equal to G M upon D square. Here distance between the two objects distance between the two objects D is equal to what, Ray? Radius of the earth. Yes or no? Yes or no, children?
Yes. Yes.
Be- because if an object is falling on the earth, then the line during the centers is nothing but equal to the radius of the earth. Yes or no?
Yes.
So ultimately important, G is equal to G M upon R square. Make a bracket for this. Make a bracket for this. This is an important derivation for the G. And then put the values. G is equal to, what is G? 6.67 into 10 raised to minus 11. How much is the mass of the earth? They have given the value 6 into 10 raised to 24. 6 into 10 raised to 24. And how much is the radius of the earth? It is 6.3 into 10 raised to 6, 6.4 into 10 raised to 6. On solving all this, see one more thing, square. Children, pay attention. This is 6.4 into 6.4. And this 6.6 and 6 will almost get cancelled. Thoda sa rahega. Kya rahega? Almost nothing will remain. So 10 raised to 11, 10 raised to 24, and 10 raised to 12. So 24 minus 11 remains 13, and 13 minus 12 remains 10. Means here approximately remains only 10. How remains 10? See what I'm writing. 6.67 into 6 into 10 raised to 24 minus 11 upon 6.4 into 6.4. Huh? So approximately 6.4 and 6.6 gets cancelled. 6.4 and 6.6 gets cancelled. And into 10 raised to 12. 6 square is 12. So here ultimately 10 raised to 13 upon 10 raised to 12. That is 10 raised to 13 minus 12. That is equal to 10. And if I would have actually calculated what 6.67 into 6 divided by 6.4 into 6.4, I would have got 0.98. Okay. And ultimately 0.98 into 10 would have given me 9.8. Are you understanding how this value came as 9.8 meter per second square?
Yes, sir.
Yes.
This is now the standard value. G is equal to 9.8 meter per second square. Again, highlight the value of G. G is nothing but 9.8 meter per second square. You can also sometimes take it as 10, approximately equal to 10. Yes or no?
Sir.
Yes.
Finish writing, all of you. Did you understand what is happening?
Yes, sir.
So that's the value of G for us. Now, motion of objects under the influence of gravitational force of the earth. Let us do an activity to understand whether all the objects, this is an important point, hollow or solid, big or small, will fall from a height at the same rate. See what? Important question. Always you will be asked this question in the exams. You imagine, I have taken a piece of paper. You do this activity practically. Take a piece of paper and just from the second or first floor, just throw it down. Just leave it. Throw means leave it. Very slowly and steadily it will come and fall. From the same height, if I throw a heavy object like a mobile phone, will it fall with the same speed or with the greater speed?
No.
Greater speed.
Greater, obviously. If I throw a hollow box and if I throw a heavy box, which box will reach Earth at a faster pace?
Heavy.
The heavy box. That is, but naturally we understand. But tell me, okay, now, ये तो था एक पेपर और इसका एग्जाम्पल. If I take a box and an exactly identical box, same size, same measure, everything same, say 5 by 5 by 5, 5 length, 5 meters length, 5 meters breadth, 5 meters height, of made up of wood. Another box made up of wood, 5 meter length, 5 meter breadth, 5 meter height. 5, 5, 5, 5, 5, 5. Exactly identical two things. Exactly identical. But first box is hollow. Second box is filled. With second box, I have kept a 10 kg का weight into that. अपना जो weighing balance का weight होता है. But both the boxes are 5 by 5 by 5, 5 by 5 by 5. And now I'm throwing these two boxes. Who will come down faster?
Box A.
I'm not getting you. Obviously, the heavier box will come down faster. You can do that experiment. The heavier box will come down. But practically speaking, what should happen? Practically speaking, when they are under a free fall, they will experience the same acceleration of 9.8 meter per second square. Yes or no?
Yes, sir.
They will experience the same acceleration. So they both should fall with the same speed. Why? Because they're experiencing the same acceleration. But again, what do we know? Force is equal to mass into acceleration. Now, the impact force created by the heavier box would be more because mass is more. So mass into acceleration. But the time required will be same for both the boxes. Are you understanding?
Yes.
Because what is acceleration? Rate of change of velocity. So that rate is same for both because they are experiencing the same acceleration due to gravity. Are you understanding?
Yes.
Only if one object is bigger and one object is smaller, obviously the smaller object will come down faster. Why again? Because practically there is an air resistance. When I threw that page, the page is having a more surface area. So more air is resisting to it. So this page is trying to come down because of acceleration due to gravity. Air is blocking its motion. So वो ऐसे आराम से हिलते डुलते आराम से आएगा. But the stone is a very small stone. It has got a very less amount of air friction because the surface area itself is small. So less air resistance, it will fall down faster. Where in this environment, when there is a air existing, But if I had created a vacuum room, you might have seen a video last year. Smita teacher had sent it on our groups. If a vacuum room is created and you throw a weight of 50 kgs and a feather is almost weightless. feather मतलब एक dove, किसी पंछी का पंख, वो feather को छोड़ दो and वो weight को छोड़ दो, they both will come down and fall in a vacuum. Why? Because there is no air resistance. Just a minute. Hello. And that is a brilliant explanation of the acceleration due to gravity. If that video is available with me, I will send it to you today again. What? In a vacuum, only gravitational force is acting, and you just leave two things. What? One feather which is almost weightless and the 10 kgs, 100 kgs ka weight. Both will come down at the same rate because of acceleration due to gravity, 9.8 meter per second square. But the same two things in this environment, if I leave, obviously the weight will come down faster. Why? Because it has got more weight, air resistance is least. But in ideal situation, in vacuum, let it be big or small, heavy or hollow, every object will fall with a constant speed. Are you understanding this part, children?
Yes, sir.
When will they come down with the same rate? Only when there is a vacuum. No other force is acting apart from Earth's gravitational force. In a vacuum also gravitational force. What did I say? Universal law. It is applicable everywhere in the universe, whether there is vacuum, whether there is no vacuum, whether there is atmosphere, no atmosphere, celestial, terrestrial. Everywhere there is vacuum. Everywhere there is gravitational force. So if in the case of a vacuum, if you are able to create a vacuum, and then send two objects, they will fall down in the same rate. Or else, objects with higher mass will fall down faster. Okay? Do we understand?
Yes, sir. Yes, sir.
Fine. So here we'll stop for the day. If I have that video available with me, I will send it to you today. Goodbye, all of you. Hello. हो जाऊ